CBSE Class 10 Math. We are doing chapter-wise revision. We are in chapter 12, areas related to circles. This chapter has got exactly 4 concepts. The first and second are essentially nothing but formulae, area of circles and circumference of circles. Third and fourth involve a little bit of analysis and you need to know some concepts about what are sectors and what are segments. Third one is area of sectors, both minor sector and major sector. The last one is area of segment, minor segment and major segment. We'll invest a lot of time in this. We'll quickly run through these two parts. Area of a circle formula is pi r square, where r is the radius of the circle, and circumference of a circle, the formula is 2 pi r, where r is the radius of the circle. Let's do a couple of questions, consolidate both these formulae and then move on to sectors and segments. First question, find the area of the circle whose circumference is 44 centimeters. Formula for circumference is 2 pi r. Formula for the area is pi r square. We're going to break solving this question into 2 steps. Step 1, let's compute the radius. Step 2, let's compute the area. Pause the video right now. Find out the radius using this information. Substitute this in this formula, find out the area. Come back to the video to verify the answer. Hope you have done it. Let's quickly run through it. Step 1, we're going to compute the radius. Circumference is 44. Formula for circumference is 2 pi r. Unless the question states otherwise, take pi to be a 22 by 7. In some questions, they'll say take pi to be a 3.14. In that case, we'll go with a 3.14. Here 2 pi r is equal to 44. I'm substituting this pi as a 22 by 7 to compute the value of r, which is 2 times 22 by 7 times r is equal to 44. Divide both sides of the equation by a 44. 44 on the left hand side, 44 on the right hand side. Both of them get cancelled. So you'll be left with a 1 on the right hand side. Cross multiply. Radius is equal to 7. Step 1, we have found out the radius. Step 2, we're going to plug in the value of radius in this formula pi r square. Pi again is a 22 by 7. Radius is 7. 7 times 7. 7 square. Cancels out to leave us with an area of 154 centimeter square. Right? Very simple question. A 1 mark question probably. Running through the steps in a printed form. Computed the radius to be a 7. Plugging it into this 22 by 7 into r square. That gives us an answer which is equal to 154 centimeter square. More to the second question. It's a little more interesting. The wheels of a cycle are of diameter 70 centimeters each. How many complete revolutions does each wheel make in 7 minutes when the cycle is traveling at a speed of 22 meters per minute? The diameter is given in centimeters, the speed is given in 22 meters per minute, and the cyclist is traveling for 7 minutes. What we are going to do is basically we are going to compute the distance covered in 1 revolution. And we are also going to compute the total distance covered in 7 minutes. 1 revolution, let's say x is the distance covered, and the total distance covered in 7 minutes is equal to t meters. Then the number of revolutions is equal to total distance divided by the distance covered per revolution. Quickly run through all of this in a printed form and then start solving this. Diameter of the wheel is given, so radius of the wheel is 35 centimeters. Keep this in mind. The speed of the cyclist is 22 meters per minute. The duration for which the cyclist is traveling is 7 minutes. Approach, compute the distance traveled by the each in 1 revolution. The distance traveled by the wheel in 1 revolution is going to be equal to the circumference of the wheel. That's the distance covered in 1 revolution. Step 2, let's find out the total distance traveled in 7 minutes. Lastly, we'll find out the number of revolutions done while traveling for 7 minutes at 22 meters per minute. Step 1, we're going to compute the distance traveled by the wheel in 1 revolution. Distance traveled by 1 revolution is nothing but the circumference of the wheel. Formula for the circumference of the wheel is 2 pi r. Take pi to be a 22 by 7. We know the radius is equal to 35 centimeters. So this is 2 times 22 by 7 into 35 in terms of centimeters. We'll get the distance traveled in 1 revolution. 7 gets cancelled with 35 to leave us with a 5. 2 into 5 is a 10. 10 into 22 is equal to 220 centimeters. The speed is given in meters. So let's write the distance covered in 1 revolution in terms of meters. 100 centimeters is equal to 1 meter. Therefore, we have 220 centimeters can be written as 220 centimeters is equal to 220 divided by 100, which is equal to 2.2 meters. So in 1 revolution, this wheel covers a distance of 2.2 meters. Step 2, let's compute the distance traveled in 7 minutes. Distance covered is equal to speed into time. Speed is given as 22 meters per minute and we're traveling for 7 minutes. So distance covered is going to be 154 meters in this entire 7 minutes. Each revolution is 2.2 meters. total distance traveled is equal to 154 meters. So number of revolutions is equal to total distance traveled divided by distance per revolution. Total distance traveled is equal to 154 meters. Distance per revolution is equal to 2.2 meters. So number of revolutions done is equal to 70. Quickly summarize all of it in the printed form. We are computing the circumference of the circle, which is 220 centimeters. Substituting r is equal to 35 centimeters. Translating it or converting it into meters, that's 2.2 meters distance covered in one revolution. Now let's look at what is the total distance traveled. That is equal to speed into time. Speed is 22 meters per minute. Time is 7 minutes. So 154 meters. Number of revolutions is equal to total distance traveled 154 divided by the distance per revolution, which is 2.2, which is equal to 70 revolutions. Right? So done. This question is likely to be a 2 or 3 mark question. Let's move on to the next concept. We'll be looking at area of a sector. Let's first understand what is a sector. This portion I'm shading, whatever I'm shading region, this is called the minor sector. AOBP. This part is called the minor sector. The part of the circle that I left unshaded is called the major sector. So this is OAQB. This is the major sector, right? OAPB is a minor sector. OAQB is the major sector. How do we find out the area of the minor sector? Area of the circle is equal to pi r square. The angle subtended by the circle is equal to 360 degrees. This sector, the minor sector, subtends an angle of only theta. So the area of the sector is going to be theta by 360 into pi r square. Quickly run through this in a printed form. Area of the sector subtending an angle of theta is equal to theta by 360, because for the entire circle it's 360 degrees. This subtends only an angle of theta. For example, if theta is equal to 60, we'll say it's 60 by 360 into pi r square. This is called the length of the arc. This part APB is called the length of the arc of sector that subtends an angle of theta. The entire circumference is equal to 2 pi r. Angle in a circle is 360. This sector subtends only an angle of theta. So length of this arc is equal to theta by 360 into 2 pi r. Area of the sector is theta by 360 into the area of the circle, which is pi r square. Length of the arc is theta by 360 into the formula for the circumference of the circle, which is 2 pi r. The area of the sector has been computed, let's say this part, then this is a minor sector. The area of the balance, which is a major sector, is nothing but area of the circle minus area of the minor sector. So they're asking you to compute the area of this part. Compute the area of the minor sector first. Find the area of the circle. Subtract the area of the minor sector from the area of the circle to find the area of the major sector. Right? So let's move on to the next concept, which is about segment. This is called the minor segment. APB, this portion, this D-shaped item is called the minor segment. Whatever is left unshaded, all these things, including this triangle, is called the major segment. How do we find out the area of the minor segment? Find out the area of the sector, right? I'm shading this part right now. That we know how to do it. Area of the sector is equal to theta by 360 into pi r square. Now, what do we have to subtract? I need this area. I have this entire area. If I subtract the area of the triangle AOB from this, we'll find out the area of the minor segment. How do we find out the area of the major segment? Area of the entire circle minus the area of the minor segment will give us the area of the major segment. Quickly summarize this again in a printed form. Area of the segment APB, this is what we are trying to find out. This area is equal to area of the sector, as I drew earlier. This is the area of the sector minus area of the triangle. Area of the sector is theta by 360 into pi r square minus area of the triangle. We'll figure out what kind of a triangle it is and then find out the area of the triangle as the question gives us data. The type of triangle is more often than not determined by this the value of theta. Theta more often than not is going to be 60 degrees or 90 degrees. If it is 60 degrees, then the triangle is going to be an equilateral triangle. If it is 90 degrees, then the triangle will end up becoming a right triangle. How do we find out the area of the major segment? We know the area of the minor segment. Area of the major segment is area of the circle minus area of the minor segment. This area I want. So what am I going to do? From the area of the circle, I'm going to subtract the area of the minor segment. Let's quickly run through a few questions. We're going to be doing about 5-6 questions to consolidate this idea. Start with the first one. A coin is made with bronze wire, right? The coin is not going to be a filled coin. The coin is going to be made with this shape is made of the bronze wire in the form of a circle with diameter 42 millimeters. The diameter of the circle is equal to 42 millimeters. The wire is also used to make 5 diameters which divide the circle into 10 equal sectors. We need to find out two things. The total length of the bronze wire used. And second one, area of each sector. 10 equal sectors, we need to find out area of one such sector. Let's get started. Here's the data that's given to us. The diameter of the coin is 42 millimeters. So radius is equal to 21, half of that. It's been divided into 10 equal sectors using 5. This is diameter 1. So 1 is one diameter, 2 is the second diameter, 3 is the third diameter, 4 is the fourth diameter, and 5 is the fifth diameter. So we're using the wire 1 for the circumference and for these 5 diameters. First thing we need to find out is the total length of the wire used. But before that, we'll do one simple calculation because these are all equal sectors. Let's find out the angle subtended by each sector. 360 degrees is the angle in the entire circle. We have 10 equal sectors. So angle subtended in each sector is going to be 360 upon 10, which is equal to 36 degrees. So each of these angles, each angle is going to be 36 degrees. Step 1, let's find out the total length of the bronze wire. That is equal to wire used for making these 5 diameters plus the circumference of the coin. Each diameter is equal to 42 meters. 5 such diameters, the wire required for it is 5 into 42, which is equal to 210 millimeters. This part is straightforward. This again, we just need to substitute in the formula for circumference of the circle, which is 2 pi r, 2 into 22 by 7, which is the value of pi, into r. If the diameter is equal to 42, the radius is equal to 21. Cancels out to leave us with a 3. 22 into 2 is a 44 into 3, which is equal to 132. So circumference of the coil is 132. The diameters totally add up to 210. So the total length of wire required is the sum of these two, which is equal to 342 millimeters. So much wire is required to make what you have got done here. Step 2, let's find out the area of each sector. Area of a sector we know is theta by 360 into pi r square. Theta we found it to be equal to 36. 36 upon 360 into pi, which is 22 by 7. R is equal to 21. 21 times 21. Cancels out to leave us with a 10. 10 gets cancelled to leave us with a 5 here and a 11 here. 7 gets cancelled with a 21 to leave us with a 3. So what we have is 33 into 21. We'll find out what that value is. 33 into 21 is 33 into 20 is 660 plus 33, which is 693 divided by 5 is the answer, which is equal to 138.6. Quickly run through this in a printed form. 36 by 360 into 22 by 7 into 21 into 21. This cancels out to leave us with the 3. So kept the 10 as it is. This 36 and 360 will cancel to leave us with the 10. 22 into 3 into 21 divided by 10. So 22 into 3 is 66 into 21 is 1386 divided by 10, which is 138.6 millimeter square. Move on to the next question. Here finding out the area of the minor segment of a circle whose radius is 21 centimeters. If the length of the corresponding arc is 33 centimeters, they have not given us the angle subtended by it. Instead, they have given us the length of the corresponding arc. This arc length is equal to 33 centimeters. Radius is equal to 21 centimeters. What is the approach? Step 1, let's find out this angle theta. Angle subtended by this sector at the center of the circle, angle AOB. We'll use angle AOB to compute the area of the sector. We know now theta at the end of step 1. We know the radius. So theta by 360 into pi r square will give us the area of the sector. Then let's find out the area of this triangle, which is AOB. From OADB, sector area, let's subtract the area of the triangle to find out the area of the minor segment. Step 1, let's find out this angle subtended by the sector at the center of the circle. We know the length of this arc is equal to 33. Length of the arc is equal to theta by 360 into 2 pi r. That is the 33. So theta divided by 360 into pi is a 2 times pi is a 22 by 7 into radius, which is equal to 21, which is equal to 33. The only variable in this is theta. Let's find it out in a minute. The 7 gets cancelled with this 21 to leave us with a 3. So let's compute the value of theta. Theta is equal to 33 times cross multiply this 360 divided by, in the denominator we'll have a 2 times 22 times 3. 3 gets cancelled with this 33 to leave us with 11. 11 cancels with this 22 to leave us with a 2. So 360 by 4, 90 degrees is the angle subtended at the center. Step 2, let's find out the area of the sector. Area of the sector is theta by 360 into pi r square. What is theta? Theta is equal to 90 divided by 360 into pi, which is a 22 by 7. R square, R is a 21, so 21 times 21. This gets cancelled to leave us with a 4, gets cancelled to leave us with a 2 in the denominator. 7 gets cancelled with this to leave us with a 2, with a 3, I'm sorry. So what we have is essentially 21 into 3, which is 63 times 11, 63 times 11 divided by 2 is the area of the sector. 630 plus 63, which is 693 divided by 2. 700 by 3 is essentially 350. 7 by 2 is a 3.5. This is equal to 346.5. So the area of the sector is 346.5. Let's find out the area of the triangle. But before that, let's consolidate both these steps. Found out the angle to be equal to 90 degrees. Plugging in the value of theta as a 90 degrees. Found out the area of the sector, this entire portion, to be equal to 346.5. I'm going to find out the area of this triangle. If theta is equal to 90 degrees, then the angle between AO and OB is 90, which means it's a right triangle. Area of right triangle AOB is equal to half into base into height. The base is the radius, height is also the radius, so this is equal to half into 21 times 21. 21 square is a 441. 441 divided by 2, this is equal to 220.5. So area of the triangle is 220.5. So the area of the segment is area of the sector, which is equal to 346.5 minus area of the triangle, which is 220.5. 0.5 and 0.5 gets cancelled. We're left with 126. So the area of this minor sector is equal to 126 centimeter square. Quickly run through the area of the triangle and computing the area of the segment in the next two slides. Calculate the area of the triangle, which is half into base into height, because it's a right triangle. That works out to 441 by 2, 220.5. Area of the segment is equal to area of the sector, 346.5, minus area of the triangle, 220.5, which is 126 centimeter square. Let's move on to the next question. It's a very interesting question, lovely question. We have 4 equal circles, which means that the radius of all of these 4 circles, let's call it as 1, 2, 3, 4. All of these radii are equal. Let's say the radii are all equal to r. 4 equal circles are placed inside a square such that each circle touches 2 adjacent sides. So each circle, you'll find that will have 2 adjacent sides, it touches it, and 2 other circles externally. So let's look at circle 1. It touches circle 4 here and it touches circle 2 here. You'll realize that each of these circles is touching 2 other such circles externally. The side of the square is 28 centimeters. This entire thing is equal to 28 centimeters. We need to find out the area enclosed by the 4 circles. Area enclosed by the 4 circles is this area. We need to compute this area. Quickly run through this diagram again here. This is 28 centimeters, side of the square. Let D be the diameter and R be the radius of each of these small circles. E, F, G and H are the centers of these 4 equal circles. If 2 circles touch each other externally, the distance between their centers is going to be equal to the sum of their radii. These are equal circles. So radius of this circle is equal to r. Radius of this circle is also equal to r. So distance between their centers is going to be equal to sum of the radii, which is equal to 2r. So this will be a 2r. So will this be a 2r. So will this be a 2r. And so will this be a 2r. Right? This is what we have. Each circle touches 2 adjacent sides and 2 circles externally. So distance between the centers of any 2 circles will be the sum of the radii. They are same, equal circles, which means the radii are same, which means this is r, this is r. The distance between their centers is going to be equal to 2r. Quickly get down some more points. The side of the square is equal to 28. Look at it. This is a diameter of one of the circles. This is the diameter of the second circle. Both are equal circles, which means sum of their diameters is equal to 28. Diameter is 2 times r, so 4 times the radius is equal to 28, or each of these radii is equal to 7 centimeters. We found out the radius of each of the circles. We need to find out this area. This area is actually nothing but the area of the shape EFGH. We deduced all of these things to be equal to a 2r, which means that EFGH is going to be equal to a square, because all are equal squares. equal circles, distance between the centers of any pair of the circles will be equal to all other pairs, which means this is 2r, this is 2r, this is 2r, this is 2r. We have EFGH as a square of side r plus r, which is equal to 14 centimeters. We need to find out this area. How am I going to go about it? I'll first start by finding out the area of this entire square. It's very simple. Now that we know the side of the square, it's 14 square, which is equal to 196. From this, let's subtract the area of 4 sectors. This is the sector 1, this part. This is sector 2, sector 3 and sector 4. Let's subtract the areas of 4 of these sectors. We'll get the area of what we need to find out. Angle subtended here is equal to 90 degrees. So area of each sector is theta by 360 into pi r square. Theta is a 90 divided by 360. All are equal circles. So the radius is going to be the same, which is equal to 7 for each of these sectors. We have 4 such sectors. Right now we are computing the area of one such sector. 7 gets cancelled with 7. This will leave us with a 4. 4 gets cancelled with 22 to leave us with 11 in the numerator and a 2 in the denominator. 77 by 2, which is equal to 38.5. So area of one sector is 38.5. We have 4 such equal sectors. So area of all of those sectors is 4 times 38.5, which is equal to 154. Conversely, you could have done one thing. We have 4 sectors. All these sectors are of equal area. Each sector is of subtends an angle of 90 degrees. So all 4 together will subtend an angle of 360 degrees. 360 degrees subtending an angle at the center means that we are talking about one circle. So instead of finding out the area of one sector and then multiplying it with a 4, you could have found out the area of one circle of radius 7, which would have been the same 154. Area of the square is 196. Area occupied by these 4 sectors is 154. So area of interest to us is the difference between these two, which is 196 minus 154, which is a 42. Consolidate all of this in a printed form. Just spoken about these things. We have found out the area of each sector. 90 by 360 cancels out as a 4. 7 gets cancelled with the 7. The 22 and 4 will cancel to leave us with 11 in the numerator and 2 in the denominator. 77 by 2 is a 38.5, which is the area of one such sector. Area of all 4 sectors therefore will be 4 times 38.5, which is 154. Area of the square is 196. Area of the 4 sectors taken together is 154. The difference between the two is the area that we need to compute. That is 42 centimeters square. Move on to the next question. This was a question given to us in the sample question paper also. So let's quickly run through it. We've given a number changed version of it. This number given in this question are different from what we see in the sample question paper. So it gets one more practice for this question. Following figure depicts a racing track whose left and right ends are semicircles. So both of these are semicircles. That's what they're saying. The distance between two outer parallel line segments is 70 meters. So this distance, this is equal to 70 meters. And they are each 106 meters long. So this length is equal to 106 meters long. The track is 14 meters wide. So the width of the track is equal to 14 meters. We need to find out the area of the track, which means this entire part we need to find out. The entire part, if you look at it, comprises two distinct geometrical shapes. This part is a rectangle. This is a rectangle. So you have two such rectangular shapes. This is a semicircular shape. You have an arc. Essentially, you have a semicircular shaped wedge is what you have got. So we have a semicircular shape for which we'll have to find out the area. We have a rectangular shape for which we need to find out the area. Quickly run through the dimensions again. This is 106 meters. The outer distance is equal to 70 meters. That essentially, if you look at it, if I draw this line here, this is a semicircle. This gives us the diameter, outer diameter of the track, semicircular portion. That is 70 meters. Then the radius is going to be equal to 35. This is the center of the semicircle. This is equal to 35. The entire diameter is equal to 70. The track length is equal to 14, which means the radius of the inner part of the semicircle is going to be 35 minus this 14, which is equal to 21 meters. So the semicircle, we know the outer radius, which is 35. We know the inner radius, which is equal to 21. So we'll be able to compute this area. We'll have to find out the second part, which is the area of the rectangular portion. Actually, what we'll do is we'll find out the area of the rectangular portion first, which is quite easy to find out. The length is equal to 106. Excuse me. Width is equal to 14. We have two such rectangular shapes. So rectangle area is equal to length into width. Two such, so which is 2 times 106 times 14. 14 into 100 is 1400. 6 into 14 is 84. So 1484. 2 times that is going to be the area of the rectangular portion. This is 2800 plus 168, which is 2968 meters square. Quickly run through it in a printed form. 2 times length times width, which is 2968. This is very, very simple. Next part, we're going to find out the area of both these semicircular portions. How do you find out? I'll run it here. I'm going to find out the area of the outer semicircle. From that, I'm going to subtract the area of the inner semicircle. So we have two such semicircles, 2 times. Area of a semicircle is half of the outer semicircle. So that is going to be equal to pi into r square. If this is equal to r, the outer radius is capital R. The inner radius is small r. So subtract minus pi r square. So this will give us the area of the triangle. We're finding out the area of the outer semicircle, subtracting the area of the inner semicircle. So whatever is left is going to be the area of each such semicircular track. We have two such, so 2 and this will get cancelled to leave us with the area of the tracks that we'll have to cover in the semicircular portions to be pi into capital R square minus small r square. This we can write it as, take the pi common, into r square minus r square, which is equal to pi into a square minus b square is an a plus b into a minus b. So r minus r into r plus r. Pi is equal to 22 by 7. Capital R is equal to 35, that we know. Small r is equal to 21. So r minus r is 35 minus 21. R plus r is 35 plus 21. So this is equal to 22 upon 7 into 35 minus 21 is a 14. 35 plus 21 is a 56. This cancels to leave us with a 2. So what we have is a 44 times 56 as the area of the semicircular tracks that we have, both the tracks. Find out what is 56 into 44. 56 into 44. This is a 24, 2 carried over, that leaves us with a 22. Again a 224. So 4642. So 2464 is the area of the semicircular track. Quickly summarize it in a printed form. Pi into r square minus r square, 35 square minus 21 square. Here I've actually done it a little differently without going for a plus b into a minus b. This number works out to 784. 22 into 784, this will cancel out as 112 to give us an answer 2464. We computed the area of the rectangular track to be at 2968. The semicircular track is 2464. So overall area of the track is the sum of these two. 8 4s are 12, carry over 1, which is a 13, 3, carry over 1, which is a 14, carry over 1, which is equal to 5. 5432 meters square is the area of the entire track, which includes both the rectangular portion and the semicircular portion. Lovely question. Just take one more minute. The same question is also given to you as part of the sample question paper solution. That comes with a different set of numbers given by CBSE. So you get 2 questions to practice. If this question appears, you should definitely get it right. The last question. AB and CD are 2 diameters of a circle whose center is at O. And these 2 diameters are perpendicular to each other. OD is the diameter of the smaller circle. OA is equal to 7. OA is one of the radii. The radius in any one part is 7. The radius in all parts is going to be 7. So OD, the diameter of the smaller circle, is 7. The radius of the smaller circle is going to be equal to 3.5. They've asked us to find out the area of the shaded region. It includes the small circle. I'll call it as region 1. And it includes these 2 parts, 2 and 3. The 2 and 3 actually is nothing but, we'll see how to go over it, the semicircle minus area of the triangle. So what we have is the radius of the larger circle, which is 7. So diameter of the smaller circle is 7, radius of the smaller circle is 3.5. Deduce these 2. What is the approach? Compute the area of the smaller circle, which is pi r square. Straightforward. We know r is 3.5. This portion can be done. Compute the area of this semicircle. We know the radius is 7. Pi r square by 2 will give us that. Let's compute the area of this triangle ABC after that. We'll figure out how to do that. This is 90 degrees. So AB is the base, OC is the height. So from the area of the semicircle, if I subtract the area of the triangle, we get areas of regions 2, 1, 3. To that add area of region 1, we have the answer. Start with region 1. Area of the circle is pi r square, which is 22 by 7. I'm taking r to be a 7 by 2 just to make calculations easy. 7 by 2 and 7 by 2. This entire thing is 7, so 7 by 2. 7 gets cancelled with 7. 22 gets cancelled with the 2 to leave us with 11. 77 by 2, 38.5 centimeters square is the area of the circle. So portion 1 done. Step 2, let's find out the area of the semicircle. Here the radius is equal to 7. So that is equal to half into pi, which is a 22 by 7, into r square, which is 7 times 7. 7 gets cancelled with the 7. 22 gets cancelled with this 2 to leave us with 11. So area of the semicircle is equal to 77 centimeters square. This is 77 centimeters square. Let's find out the area of the triangle. Area of the triangle, AB is the base. So 7 plus 7. AB is equal to 14. This is perpendicular. So OC is the height. OC is equal to 7. So area of triangle ABC is equal to half into the base 14 into the height, which is equal to 7. 14 gets cancelled with the 2 to leave us with the 7. 7 sevens are 49. So part 3, which is the area of the triangle, this portion is equal to 49. Let's find out areas of regions 2 and 3 taken together. 2 plus 3, the area is equal to area of the semicircle, which is 77, minus area of the triangle, which is equal to 49, which will leave us with an answer which is equal to 28. So area of the shaded region is area of part 1 plus areas of parts 2 and 3. That is a 38.5. Total area of shaded region, entire area is 38.5 plus 28, which is equal to 66.5 centimeters square. Summarize it in a printed form. Step 1, finding out the area of the small circle. Radius is 3.5, 38.5. Step 2, we are finding out the area of the semicircle with radius as 7, half into pi r square, which gives us 77 centimeters square. We're going to compute the area of the triangle. Height being 7, base being 14, these two being perpendicular to each other, which means OC is the height, AB is the base. So AB is the base, 14, OC is the height, 7. Area is equal to half into 14 into 7, which is 49. Entire semicircle 77. Area of this triangle is equal to 49. So areas of regions 2 and 3, which we computed, is the difference between these two, which is equal to 28. 28 plus area of this circle is equal to 66.5 centimeters square. When all was this concept tested? Look at it. Every single year we seem to have a question on it. 2016, 3 questions. 17, 3 questions. Sample paper 19. Actual board paper. Sample question paper basic. We had 3 questions. So this is a topic which is quite important. Especially the second and first concepts are very, very easy. You don't have to worry about it. Third and fourth, which talked about both the areas of the sector and the area of the segment. Invest time, understand what we are trying to find out, and then go about and finding it out. Note one thing, quite often the theta given to you, if you're trying to find out the area of the segment, is going to be either 60 degrees or it's going to be 90 degrees. If it is 60 degrees, I'll draw it once again and consolidate this idea. We're talking about this being the chord, and then this angle is equal to 60. This being radius and this being radius, we're talking about an isosceles triangle. Theta and theta, because these two sides are equal. So 2 theta plus if the central angle is a 60, that will be equal to 180 degrees, which means 2 theta will be equal to 120. Theta is equal to 60. So 60, 60, 60, it becomes an equilateral triangle. So the angle in the center is 60, the triangle is an equilateral triangle. Area of equilateral triangle, we have learnt it in class 9, which is root 3 by 4 into a square. In this case, it's going to be r square. If the angle at the center is equal to 90 degrees, then we are talking about a right triangle. Area is equal to half into base into height, which is equal to r square. So these two things you can take for granted. They're not going to give you a 75 degrees or a 62 degrees or any of those things. It's going to be 60 or 90. Best wishes. Before you leave, do 2 things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. Takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.